Hello everybody and welcome to this webinar. My name is Lee Snyder, the product manager for the Steel segment here at Trimble, and I'm pleased to introduce you to our Partner Spotlight webinar series focusing on our fabrication partners with Tekla Structures. Today our Fabrication Partner Spotlight will focus on Steel Projects, which is part of the Ficep group. Before we begin, I just want to introduce you to a couple housekeeping items. As you joined the webinar today, you were placed on mute due to the volume of those that are calling in. If you do have any questions throughout the webinar, we encourage you to ask those and type those in the questions window that you can see there on your GoToMeeting interface. We'll do our best to answer all of those that we can throughout the webinar, and if we're not able to get to all of them, we'll reach out to you individually after the webinar. I'm happy to introduce to you Paul Hardman with Steel Projects, who will be our presenter for today. He's going to walk us through the link that they have with Tekla Structures, as well as some other solutions that they have available for you. So without further delay, I'm happy to hand this over to Paul.
Thanks, Lee. A little bit about myself. My name is Paul Hardman. I do sales for North American market for Steel Projects. I joined Steel Projects in July of last year. This is my sixth year in the steel fabrication industry. I worked in another software on the market, and before that I was a structural steel fabricator. I learned all of this while pursuing a degree in theoretical linguistics from Indiana University in 2010. You have my contact information below there as well. So let's get started to discuss some of the benefits of the unique integration that we have with Tekla and Steel Projects to then program Ficep and some non-Ficep machines. A little bit about us. Our company, we're the software provider for steel fabrication since 1994. We were acquired by Ficep in 2012. We have over 2,000 customers worldwide with offices in the United States, in Canada, and France. Our software is called Steel Projects PLM, technically. We're a product lifecycle management, and our focus is really on production. We'll discuss a lot throughout this webinar about how we're different from any other software on the market, that we're solely focused on production, running machines, and getting various types of feedback from machines and manual workstations. We're a scalable solution, so we have options available for a very small mom and pop fabricator that has one angle line or one beam line, all the way up to a fully automated handling system or a large enterprise solution with multiple workshops across multiple states into one singular point of contact of software. Our association of software with machines, in other words, our CNC data creation for all types of machines with feedback, is really what we call the intelligent steel fabrication software. And as we walk through this, we'll see exactly why we are so unique. So sort of the rough roadmap of where we're going and where we're positioned in between Tekla and Ficep is we basically bring in drawings from the detailing office to manage the production office to then optimize the workshop. So we're situated right between Tekla and the machine. Our software consists of many different modules, many different features available, and we're really going to focus on how Tekla really is a great fundamental tool in getting the clearest, best data from the detail model all the way down to the machine itself. So over here on the right, we'll see these interesting little icons right here from Tekla, and this little bar and plate all the way down to the truck. We'll really focus on what we do, this sort of a roadmap of where we're going. We're going to discuss the Tekla XML format, our proprietary XML format. We're going to discuss some project and production planning, as well as the material planning and CNC data creation. We'll then go into some of the workshop assistant applications that we have to really get some good feedback of machine and shop efficiency, as well as our transportation management module as well. You can sort of see the workflow we're discussing, and sort of the roadmap we're going on is the workflow, typical workflow of a steel fabricator. So most should find this highly logical and straightforward. So how do we link with Tekla Structures specifically? Well, in the store there is a Tekla XML, a Steel Projects XML format that allows you to basically export the entire model in one unique proprietary XML file. So you just go in there and you type in XML, you'll see Steel Projects XML, and a free little add-on, you add that on, and then export the XML file for us to then import in. So very, very simple. So this XML format really allows for a continuous flow of information to production. Import that file into Steel Projects, and so you can see the project, phase, assembly, and part information all transferring over from Tekla XML. And from Tekla. And we'll see some of the very rich or sort of advanced features that makes the Tekla XML import really unique amongst any other software on the market. So what are these benefits that I've been talking about? What really is it that sets us apart? Well, the big one that we really pride ourselves on is the 3D visualization of assemblies. And when you export it from the model, that assembly information is set in the XML code. We then import all of that information in. And upon the import, we recreate not just the component, not just the pieces as set in the model, but the entire assembly as well. So you can get some, we have a nice little assembly here, and there any bit of assembly you have set in the model, we can get that 3D visualization. Very unique to the Tekla Steel Projects partnership. Another benefit we have is our automatic scribing of pieces positions. What that is that if the scribing is able to be done on the machine itself, we can import that scribe information if we want. Anything brought in, from the model, we want to bring it in. We can bring in that scribing the positioning of the connecting pieces on the main member. So when the pieces meet up, the components meet up for the assembly, we can have the main member carry that scribe information of it, eliminating the time at the workshop that the welder or the fitter may need to actually measure all of it out. So very, very unique benefit of bringing in that scribe information from the model to then send down to the machine. Another huge benefit, it's not just the actual importation or the bringing in of the scribing from the model. We can actually optimize that scribing. Very, very unique. So rather than here we have this HSS that might connect to a beam, in the model, if there's a tube connecting into a beam, it might have a scribe outline the entire perimeter of the HSS itself. Well, that, to scribe that bit of information might be not an efficient use of the machine if you don't want it. So we have the capabilities with this Tekla XML import to modify that scribe information to really give a bare bones of the scribe, to sort of configure the scribing on import or in various other means to then allow the scribe to really just use the critical areas of that outline so you can save scribe time, so you can then get it to the workers so then they can go and fabricate the material efficiently as well. So you can see rather than the entire outline of that HSS, we just have some corners and a little bit of 10 millimeters on on each individual side. So really, immediately we see upon importing from Tekla into Steel Projects, we already see some time saving at the machine, time saving and the cost with it, all the way down to the workshop, already in one single import, one single file. Another benefit we have, which is very unique, is we can apply any weld symbols that are set in the model and brought across. And we can have those weld symbols then be applied via scribing to members itself, an automatic scribing of the weld symbols. This is a very next step, if you will, of most shops that really want to go paperless to really bring in, see the 3D visualization of the piece, and then have this come in to see the actual welding or the weldment requirements for the members as well, to really limit or reduce any paperwork needed for the shop. Again, a very unique bit of information brought in from that Tekla XML file. And another one is the automatic marking of part identifications. So when you bring it in, it's automatically marking. We can automatically mark any of the submaterial that may attach onto that main member. So these gusset plates over here can be brought in with the part identifiers associated with it that could then be used as marking or scribing on the beam. So already on import, we have that 3D assembly itself, bringing in scribe, optimized scribing, and the part marking associated with it as well on that main piece, so that when the fabricator goes to assemble the piece, all of it is already set there on the main member itself. So those are some of the main benefits of bringing in a Tekla XML file. We'll discuss some more of how the upstream flow of information of how we have a 4D link with Tekla Structures further on. But let's really go into what, after we bring in that Tekla, that model, we bring it in. Let's discuss some of the real big benefits of Steel Projects itself, and what are we actually focused on. In this part, let's focus a bit on the project planning phase. Steel Projects allows us, as we saw, the 2D and 3D visualization of assemblies and parts. Another feature we have in this project planning phase is we have an integrated drawing editor, a very basic drawing editor that allows you to make quick, on-the-fly changes to a drawing, to a piece itself, that would then go down in code for the machine to actually read. So rather than making a full change, if typically there might be a quick change that we have, from the shop, come all the way back up, rather than getting it into code to go then export it down to the machine, rather than having to go to the model and remodel it, redetail it, re-export it, in Steel Projects, you can open up the drawing itself. You can open it up in this little drawing editor, make a little bit of a change, like a diameter change for a hole, adjust a miter, any bit of information, to then send it down to the machine itself. Another in our project planning phase of our workflow is we have an automatic part checking and validation. It's a very unique scenario, a very unique product that we very much pride ourselves in. And what that is that checks for any and all errors that might occur on the machine, on machine capability, of workstation capability, from a not optimally drawn or detailed model. So, for example, if a scribe line was accidentally set in twice in the model, when we import it in, those double scribe lines will still come across in. And if it's not caught automatically, it would then go down to the machine, and the machine would scribe the beam, for example, and then it would go back in and scribe it again, potentially damaging the tool. What we do in our part checking and validation is we review the drawing and we look for some of those double features. We look for both the drawing, how it's actually detailed, like is the part mark off the actual beam? Is it on the other side of the workstation? I'm sorry, of the material, and the machine can't actually do it. And we look at machine capabilities as well, such as, do we have the right drill size? Can we actually do this on here? And this allows for a advanced checking of any errors that might occur in the workshop or at the machine ahead of time in the drawing and production office. And this saves a lot of time because a few minute checks here might save 2 hours out in the workshop itself. So we have this advanced checking and validation of the drawing and machine capabilities. And we also have the ability to track revisions upon importing the revisions to see what the difference is between the two. We can view the documents, we can import drawings into it, any bit of associated documents or bids associated with the job itself. And we have some tooling technology management as well, where we can set up and define any bit of tooling that we have for each workstation, which I'll discuss shortly. So we can sort of see here's the initial import of the project planning phase of when we bring in the drawing itself. We have a breakdown of a rough bill of materials up top, but we can also see, a 3D visualization on the right, a 2D visualization on the left, and this is all on how the on how the member itself will look upon exporting out of all the various operations of the holes, of the scribe, of the marking itself. So aside from the project planning phase of it, we then go into the production planning. So it's imported in from Tekla XML with optimization of scribing, of marking, identification. We check the drawings itself. We do a tool and part checking validation to ensure everything is good. And then now we start getting into really planning the production itself. And we have different ways that we do this. And the primary one is through a fabrication job creation. And what that is that's essentially sort of a work order or a cut list, if you will. And that allows you to group across different jobs or within a job or just beams or just channels or however bit you want to then group material in to then potentially be nested or exported to the machine. So we can create fabrication jobs or work orders within a job or across multiple jobs to really optimize the shop itself. We have some workflow management as well that allows you to track manual and automatic machines, such as we can track manual drills, or a manual saw, as well as a Ficep machine, a drill or a coper, and then sort of manual workstations as well, where we want to actually track time or track hours and completion, such as assembly prep or QC or even erection as well. So we have this workflow management. We also have in this workflow management of, say, from the production office to a manual saw to a coper, then down to assembly prep and shipping. Within each workstation itself, we define all of these parameters of what the machine can actually physically do. This is really different from other software on the market in that we really define workstations and we really define, the workflow based on what machines can actually do. And that's our workstation management, as I'll discuss here shortly. We can also track estimated production times on it as well in this production planning phase, and we have a live workshop supervisor as well that gives an overview of essentially what's occurring in the shop as it occurs. So here's a sample fabrication workflow of a starting point to multiple different machines, different sites, so we can have material coming in to go then be checked, kitted, shot blasted, then routed to any bit of material itself, then to go on to sort of a galvanizer or another shop within the organization, or if you plan all of your production and you have multiple shops, you plan it in one, you can then dispatch sort of a fabrication job and send it to part of the job to one workshop, part of a job to another workshop. This sort of advanced fabrication workflow it really is unique with our intelligent steel software, because what we do essentially is when we start our workflow management of it, we can view the need of the job, so for example, coping, and then automatically route it and prep it for a coper. So in other words, if you have a drill saw and a coper within one shop, when you bring in the job, when you bring in that Tekla XML file, we read that member itself. We see all the tooling that needs to be done on it: holes, miter, camber, cope, any bit of information. And then when we go to actually send it towards a job, we can sort of pre-route it to multiple different, to the capable machines of it. This advanced workflow is for production time estimation, but really also for nesting capabilities. As we'll discuss shortly, we nest to machine capabilities. What can the machine do? Not to theoretical, rough, deliverable lengths. So that's a very unique aspect of our solution, and that partnership with Tekla as well. So many different ways to manage this workshop and this workflow of these workstations, either in a single small, starting point to one drill, or a huge enterprise solution with multiple shops to sort of export nestings and jobs to different machines to then be nested. And of course, after the production planning of phases, why do we send it to individual machines? Because then we know how to actually nest it. How are we going to do it? And that's our material planning phase. We have different options for nesting. We have a manual section nesting option, as well as an automatic section nesting. And we also have an automatic plate nesting option as well. We have advanced algorithms for both the section and plate nesting to take into consideration complex pieces and tooling. So for example, with the section nesting, we can flip pieces over if it's able to be flipped. We can rotate it sort of for miters of common cuts, or we can also put copes together so the machine, the robot won't have to cut or make as many passes to save time as well in actually producing the piece itself. For the plate nesting as well, we take into consideration complex pieces and tooling. So for example, if the plate machine can actually perform beveling, we can set that in the technology of our nesting itself, so that when we nest it, we provide ample space in between pieces to perform beveling. Or with bridge cutting, or with with common line cutting as well, or depending on the plate machine, if it's a gantry style or non-gantry style, we can take in, or work in zones, we can take all of that into consideration, the ability of the machine itself, and nest according to that. And with this material planning, we also have various reports of bill of material, of nesting reports to sort of see what is needed, and stock reports as well of what we need to order and send to procurement. So here's a little visualization of the automatic profile nesting, where we have two beams right here with some copes with it cut out. We have the trim cut. We have some lead cut, some trim cut. We have kerf application. We have the green line over here, or green section over here, is the remnant. The yellow is the highlighted piece of these two beams with the copes as well. And same, if we had some split tees, we can nest with some tees as well. And here's a visual of the plate nesting sample as well, to where you can factor into many different sizes on the same thickness of sheet, and any different type of material as well. So after the material is brought in, checked, and nested, then really what we do is we create automatic CNC data creation for any brand of machine. We can do it for Ficep machines and any other brand as well. We can do automatic feedback collection in this CNC data production, so we can get automatic feedback from Ficep machines back up, which we'll be discussing. And for non-Ficep machines, we can get some manual feedback. This includes production counting, time tracking, and traceability management as well. And actually, Steel Projects, we got our start in '94 with really this CNC data creation. That's really was our bread and butter, import drawings and this CNC data creation for the Ficep machines. And not just the CNC data creation as well of the machine, we also have two different applications, mobile applications for Android and Windows called our Workshop Assistant and our Production Assistant, our Production Analysis module as well, to really track the machine efficiency and track pieces as well. And this is a really, really great new feature that we're really trying to promote that basically allows you to track actual, how long has it started? How long have you worked on the machine itself? So in Ficep machines, we can get the feedback of automatically of the machine. Has it been cut? How long did it take for it to cut? How long did it take to drill? But for non-Ficep machines as well, we can collect some manual feedback of it being cut and manual workstations as well, such as the assembly and QC. So then we can get an overall view of this data collection of time tracking to really show how long is it actually taking to fabricate it, right? We can run reports. How are these, how long is it actually doing? The benefit of this, obviously, is much more accurate bids down the road. So we're actually, estimating to actual capabilities of the shop and know where we need to fine tune our processes. So really all of this is all of this is geared to really strengthen your efficiency, workshop efficiency, and really cut down on those soft costs and hard costs associated with the inefficiencies. And here's a view of our Workshop Assistant on the Android. And what it is, it's a really great little application where the user can sign in. You can take pictures of barcodes, of barcoded reports, log into either a piece or a nesting or shipping application or a bundle. There are different various options. But we can log into a workshop itself and just load in the drill saw and just start marking the pieces as done. Or the welder, can have a smartphone on him, or at the drawing table or wherever is convenient. Select a few pieces, start welding. Click start on a timer. Go ahead and start welding. Come back in, click stop, and it'll distribute all the time for individual or a group of pieces to then go back into Steel Projects PLM and track the production of it. You can manually type it in or take a picture with the barcode itself to track it. So a very, very excellent tool that I'm very excited about to really get much more accurate data of the workshop and efficiency of the workshop to then analyze in Steel Projects. And what does this do? Well, once all that, either automatically from the Ficep machine or manually from the web application, the mobile application, is that comes back in and feeds in a color coding of tracking of assemblies and pieces for the job, for the drawing or even component as well. So for this project here in this little screen, you can see 94% roughly were sent for production, 61% has been shot blasted, 76 has been sent at a machine. We have a little bit of part QC, no assembly or shipping, etc. So all of this information really set automatically or manually in the workshop, then comes back and is stored for an analysis and tracking of this color code application. Now, the benefit of that is, specifically with Tekla, is we have a 4D link to the Tekla model that in Tekla, we can then import that back into Tekla so we can see a color code of the stations actually produce, a color coding of where every piece is at, where the members are. Has it been shot blasted? Has it been QC'd? So you can get a high level view, even in the model itself, of what has actually happened in real time in production, creating that 4D link from the model to the workshop all the way back up into the model. A very, very unique tool with Tekla. Another solution, of course, after it's been fabricated, we also have a transportation management solution that allows you to organize any shipping, any shipments, create delivery tickets, sort of create trucks, and apply pieces to the truck and shipping tickets for that, so you can keep limits as well, weight limits for each truck, or for even a pallet, or even a boat or a train if you're shipping on something like that as well. So we have a transportation management module that really locks everything in for accurate reflection of it to get that full circle in of data. So I talked a little bit about the analysis, and the production analysis is really, that information comes back in from manual and automatic workstations, and it comes back in, and then we can then create editable charts and graphs of the production itself. And you can set it for many, many different, whatever you actually want to track, whatever bit of analysis is meaningful to your business, right? So I can track in this graph on the left of this endeavor, I can see a distribution of forecasted time with executed time and feedback being the total of forecast and executed time for each week. So I can sort of see, how much time each machine is doing. I can see how much weight is being produced. I can track a distribution of the production for a single machine on the actual drilling time, the distribution of scribing, cutting. I can even track the duration of each machine or any machine for any of this information. And what's the value of this? The value is that this analysis through this production analysis module and various reports allows you to make sound decisions to then cut out those soft costs and really fine-tune the efficiencies. This is real feedback from Ficep machines, real machine feedback from Ficep machines, and user-entered feedback from manual workstations to give you a very broad picture and accurate picture of what's actually going on in your workshop, so you can make key decisions to cut out those efficiencies for higher quality work, more efficient work, and of course that includes theoretically more money in the company's pocket. We also have another application called a production analysis tool for the Android, which is very, very unique. And what this does is this tracks machine efficiency. This tracks essentially key performance indicator analysis of machines set. So what I mean by that means I want to know, I can track on my workshop, on this web application away from my workshop, wherever I am, for various machines that I've set up, I can set up various factors that I want to track. So for example, if I want to track how much weight's been done per day, the production time of it, how many bars have been processed per day, what's the bars per hour, the weight per hour, I can get a high level view to see what's actually going on in the workshop. This is for Ficep machines with that automatic feedback coming in of what the machine can bring in. This key performance really shows us the values per day of really what we want. This red right here shows we're under where we want to be. Yellow means we're on track, roughly. And green means we're really hitting it. We're really rocking and rolling where we want to be. For various ones, this is a very excellent tool to see, if you're on vacation, if any of us ever take vacation, is that you're able to then track and see what's going on with the workshop. Within one click, you can see if a machine's down. What's it doing right now? Why is it not doing? So maybe a simple call. We need to call in and see, okay, why isn't my machine working? What's going on? Is there an error? Is it broken? Are people just on a very, very, very long break? These things happen. So really this production analysis tool and this application is a very unique application to create that link from the Ficep machine into the software that we're then pulling into a web application. So in conclusion, really what a lot of talk has been really garnered around Industry 4.0. There's been a lot of conversation these days about Industry 4.0 really being a hallmark of where our industry and where everybody is sort of moving towards. And that really incorporates a lot of different factors such as automation, connection, cloud computing, the IoT, the Internet of Things, or big data, as well as system integration to really create a unified bit of unified data set that really helps us make efficient and key decisions for our operations. Steel Projects PLM really is cognizant of this Industry 4.0 move, and we're really working towards many of these initiatives of Industry 4.0. And if we've not only we already hit all of those, many of these factors with our solution as well, and we're also moving towards it as well as the future progresses. So for example, with automation, we already have some automatic post-processor creation. The post-processor, is the creation of the CNC data for the machine. So we already create CNC code that the machine, each individual machine, can read from Steel Projects PLM. We also have automatic conveyors, and when there's automatic handling systems as well, we track and really help optimize the path of the automatic system, in feed, out feed, and all of this stuff as well. Really, with the connection side of things, we're really bringing in the mobile applications to track the actual fabrication performed in the workshop, and as in these sort of manual workstations, as well as sort of the actual real feedback from the Ficep machines. So we already have these applications developed. They're part of the standard versions of the software that we've developed, and we have a whole team dedicated to doing this, understanding that this is the next push. Again, with the cloud computing as well, we're getting an automatic feedback from the Ficep machines automatically. This includes any bit of information that machine is sending out, we're pulling in, and we're really analyzing that data, which we've seen through our production analysis. This is stuff from simply error messages that come in, such as oil low or the machine is stopped, all the way to what bar has been cut. How long is it taking to drill each piece? So we can really track that bit of information and bringing it in. And again, system integration, we work with Tekla. We integrate very deeply and very well with Tekla, and we integrate with other MRPs or ERPs on the market and other systems as well on the market to really create a holistic environment, really to have all of our fabricators and clients to be as successful as they can be. So if there are any questions that are available, or if there are any questions whatsoever, please don't hesitate to get a hold of me with my contact information. I'll be more than happy to reach out. If you'd like a demonstration of our product or any question as well, please don't hesitate to reach out. I greatly appreciate your time. And thank you.
Excellent. Thank you, Paul. We really appreciate you taking the time to come and give this presentation to us. As mentioned at the beginning of the webinar, if you have any questions that we weren't able to answer already, we'll go ahead and reach out to you individually. Thank you so much for your time, and stay tuned for more webinars from Tekla.